So we are now into our circle demonstration. In this video, we're going to calculate the area of the circumference. We're going to calculate the diameter of the circle. And then we're going to introduce you, or I'm going to introduce you to the value of constants. So I've started a program here. I included the IO_manip, which we're going to use to format. And of course, here's our main. Now remember, if you use Xcode, you may get some extra stuff in there. You can just delete them or you can leave them in. It's not a problem either way. So the very first thing we want to do is we want to declare our variables. So I'm going to use integers in the beginning. So let's do integer, and we want to do our radius. We obviously need our radius and our diameter. And you might argue, say, why do we need a diameter when you know that the diameter is 2 times the radius? And that's a legitimate question. The issue with that is it makes your program more readable when you're using diameter versus 2 times the radius. And it also, if you're using the diameter in more than one time, you are able to not have to recalculate the same thing. But in the beginning, it's always better to use more variables and just make them useful. Makes your program so much more readable. So now what we need is a double or a float. Doesn't really matter which one you use. And we'll call it W, and we're going to call this one area. And what I'm doing here is I'm doing 0.0 instead of 0. And that just helps me realize that it is a float and not an integer. Now remember that you should be commenting these things here, what each one is. So let's go now and actually do some coding. So the first thing we need to do is we need to get the radius of the circle. And that really is, actually I had diameter, radius, diameter, circumference it should be. If I were to try to compile this, it's going to give me an error duplicate. So let's go. I think I spelled that right. Hopefully I did. So the very first thing to do is ask the user, cout, what is the radius of the circle? Sounds like a legitimate question to me. So I'm going to get in the rate. Now notice I'm using cin and not getLine because I'm not able to get in using getLine, get a floating point or an integer. There are ways to do it, which you will see shortly. So let's go and do cin. Now remember, if you go the wrong way, like this, you're going to get those red squiggly lines. So let's see, we're going to do radius. And notice we have the red squiggly lines, which you're not going to get inside of Rebel, but here you will. So now we have cin get the radius. And now we don't really need to get the diameter. The reason why we don't need to get the diameter is because we know that the diameter is 2 times the radius. So let's go and do diameter equals 2 times the radius. Now you may be asking me, why am I putting a space after the 2 and before the R? It just makes it a little bit easier to read than that. So let's put that there, and let's not forget it here. So the first thing I'm going to do is I'm going to calculate the area of the circle, which you know that is pi r squared, hopefully. So let's just go calculate area of circle, and we'll do pi r squared. So let's go and do the area equals. So if you know the value of pi, it's 3.1416 and a whole bunch of other stuff. And there's different ways to do the radius squared. So let's just do the simplest way, and we'll do radius times radius. And then we're going to see out the area of the circle with radius of radius. And we'll do something different. Instead of is, we'll put is equals. And notice that I have a space before and after, and a space after the of, so that everything isn't jumped together. And we just type in area. And we need our return. So everything looks good. So let's go and run this and see what happens. And we'll make it simple so that we know we get the right answer. So what is the radius? So let's make the radius of the circle 5. So we know that it's going to be 25 times 3.14. So it should be 76 something. That's a little bit too, because pi r squared. Okay, let's make it 1. So that should give us 3.14, because we know that 1 squared is 1. And the area is 3.14. Okay, so that looks good. So that was fairly easy. So let's try now something different. And let's do 5. And now we have 78.5. Why did it say 3.14 before? And now it's got 78.5. Why isn't it 78.50? So now we're going to fix that using iomanip. So before we do this, I usually do this statement ahead of time, although you can do it together. We're going to do C out fix. That means we want to show it in decimal. And we want to set the precision to 2 decimal places. So let's do the exact same thing in here. And we'll do, I think we did 5. And now it's got 78.50. So now that looks nice. Big deal. We put it into 2 things. So now let's calculate our circumference. And now notice that we calculated the diameter here. So now we're just going to use diameter. And it's pi d. So we're going to use 3.14 times the diameter. So this time we're going to use something simple. We use 5. And so we should get 31.4. Of course, we're not going to get anything because I'm not printing it. So let's get rid of that and let's print it. See out the circumference is, and I put is this time. So now you're saying, wait, dude, you forgot the area, an end line. That's okay. In this particular case, I'll show you an alternative way of doing it. Notice I have the end line here to clear the buffer. We're just doing a C out and a C out. If you want to do this, that's okay. So, but just bear in mind, you definitely always want to have an end out to clear the buffer in here. So let's run this now again and see what happens. And we have, what is the radius? And we'll do 5. And the area of the circle, the radius of 5 is 78, and their circumference is 31.4. So now we have a dilemma, because we know that 3.14 is just a approximation of what pi is. So let's go into what is value of pi, and let's get it to, say, 4 decimal places or 6 decimal places. So we're going to start off with 4, and then we're going to change it to 6. Let's go and do pi. And let's see what we have. So we have 3.141519. So let's just copy and paste this, and we'll keep it for future reference. So normally people use 3.1416. So now you're writing a program and your boss says, listen, I don't want to use 3.14. I need for you to use 3.141592, blah, 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 blah. So now what you have to do is you have to go back and find every single time that you use 3.14 and change it. So let's start off with simple, and we'll do 3.1416. Okay, no big deal. 3.1416. So that's peachy keen, no big deal. But what happens if you're using pi 47 times and you only change 46 times? So now you run into a problem. So what you're going to do here is, why is this include there? So what you want to do is declare a constant called pi. And what we're going to do here is we're going to type the word const and pi. Notice this is uppercase. The reason why it's uppercase is that tells you that it's a constant and that it cannot be changed. And we're doing equal. Now, we're going to get an error here, and I'll explain why in a second. So let's do 3.14192. Let's just do this. That's pretty good. Now notice the squiggly line has, I don't understand why. What's wrong? Because we didn't say constant what. So now what we need to do is put in. So everything's fine. So what's going to happen here is we're going to assign the value of pi. And if I were to try to change the value of pi later on, I can't. But now let's do this. Let's change this from 3.1416 to pi. And let's leave this alone. What happens now if your boss says, oh, use something different? You don't have to do anything but change this number, and this will get automatically updated, but this one won't. So that's why you never want to use literals in calculations unless it's absolutely necessary. You know it's never going to change. So let's start off with the 3.14 right now, and we should get the same results as before. So we'll type in 5 and 75 and 30 in here. So now everything looks peachy keen in here. The radius, the circumference is, the area of the circle is 75. So let's see what's going on here. So we have pi times diameter, pi times radius. So it's 25. So right now, I don't believe we got the same results as we did before. So let's go and change this to 3.14159. And let's see what happens now. Now notice we're not doing anything else. And let's change this to 5. And so here is why it's so important that you check everything. Because 7500, 30.00 is, we're not 100% sure exactly if that's the right thing. So what you want to do is always, but you can see how important using these values are. So let's go and look at our code and see what we're doing. We declared a constant integer called pi, and now I made a glaring mistake on purpose. Notice that I changed the value of pi, but nothing happened. I don't understand. That makes no sense. So let me give you a little bit of a hint. This time, instead of area equals pi times radius, let's change this to 3. So let's run it again, leave it like this, and then we're going to run it one more time. In fact, let's just do this. Let's leave it. Let's run it one more time, I decided, and then we'll change it, and you can see the difference. So let's go in here and type in 5. And it says, so remember 75 and 30. So let's change this now to 3.14 and see if we get anything different. And we'll type in 5. Wait a minute, now it's 78.50. I don't understand. That makes no sense. Oh, I see. It should be 3.14159. Okay. But let's do this. Remember 75 and 30? Let's do this now. Let's put in 3. We'll do 5. Wait, 75 and 30. How is that possible? And the answer is very simple. Remember, we're talking about integers and floats. Integers can only hold whole numbers. So what happened here is I typed in 3.14159. But the problem is this is a double that gets converted to an integer, so it chops off everything else. So what we need to do here is we just need to change this to double. And we can change this back to pi. And let's see if that makes a big difference. So I'm hoping you understand the importance of every time you make a change, then you want to go back and run it just to see if there's any issues. So let's go and run it with the exact same thing again. And we'll do 5. And so it's 75.8431. So now let's just add some more stuff to it. So we did 3.149. And this is not going to really change it a whole lot. But let's add this there. And notice all I did was change this. I don't have to do anything else in my code. So let's run it one more time with 5. And it's really didn't make much of a difference, but that's okay. So we're looking good here. Now let's see, is include here, and why is this red? Not really 100% sure. Let's see if it gives, no, expected a file name. That makes no sense to me. So it ran without any problems, but that's something I found from time to time. You get these red squiggly lines here. And what I do, if I can't get rid of them, but I know it's wrong, and I cannot understand why this happens. First thing you could do is change this back to something different. But what I normally do is close this here and open it back up and see if it goes away, which it did. If you're going to ask me why, I don't have any answer to it. I just know that it works. So we're going to run this program one more time. Then I'll go over it. And we'll just try something different. Instead of 5, let's do 10. So now we have 3.1416. So you say, well, maybe we should think about having a little bit better precision than that, because the results don't really seem to be changing. All you have to do at that point in time is change this to whatever number you want. So let's do 4. And we'll do 10 again. And it looks a little bit different than what it did before. So that is everything. So let's go look in here. We included IOmanip that allows us to use set precision and fixed. We could also use the width as well. So if I wanted to set the width, there's a thing called SetW. So I could do SetW, and let's put 10 in. And let's run it again. We use the same value again as 10. And notice that we have this here is intended different places in here. So we probably want to put this here. And let's try that one more time. So now you can see, again, the advantage of doing one thing and testing it. So now we have that there. Well, now we probably want to put it over here instead. So now we're playing with cosmetics, which is okay. That's a neat thing to do. Let's try it one more time, and that's not gonna work. Let's get rid of those and put them here. And hopefully I can actually type the correct thing this time. That looks good. Now maybe the 3rd time's a charm. If not, hopefully the 4th time's a charm. So let's try it one more time. So now we have it looking good. This has not changed. Notice that set width only works on one time. So that is it for this video. And hopefully that will help you. We just go over this one more time. We declared variables. We declared integer. We declared double. We declared a constant. And remember that all you have to do is change this value here and it affects everything else. We got the radius of the circle. We know that the diameter is 2 times the radius. And if we wanted to, there's a function called POW. And you need to include the CMath library. That allows you to get function exponents. So if I could do radius, comma 2, would mean do the power of 2. If I did comma 3, it would be the power of 3. So I wouldn't have to type in radius times radius times radius. So either way, that's good. We're going to talk more about POW in there, which is power. And hopefully this video has helped you. And here we go. That's it.